Hi everyone, morning. My name is Pei Yan, CEO of HeyGears. Today, let me introduce you some of our clear aligner workflow that's part of HeyGears Solutions. HeyGears is a company who focuses on digital applications, especially we integrate software, material, hardware, process, and system together to focusing on the vertical applications. So for dental, we have many different solutions. Today, let me introduce you our solutions for clear aligner workflow. Okay, let's go to the slides. So for clear aligners, it's kind of product developed for decades. But in recent years, it's growing very, very fast. Everybody's talking about clear aligners. For many clear aligner manufacturers, the problems they are facing is how to produce clear aligners with most efficient way, low cost, and very flexible production lines, will satisfy the market needs and will provide a better service for their patients. So for that, after considering many different situations and the different kind of process, HeyGears developed some entire systems focusing on clear aligners. We call it clear aligner workflow. So for some clear clients' production demands, let's say it's quite different than the other dental appliance. For some dental appliance, each patient only require one or two dental appliance. But in clear aligners, it's like one customers will require more than one. It's like sometimes 20 steps, sometimes 40 steps, sometimes even 60 steps. I've seen in China a lot. So let's do a simple calculation, see what kind of challenge we are facing right now. If for the average, if one patient requires 25 steps and each step requires two models and clear aligners for upper and lower jaw, so if you print 10 patients a day, that you are facing at least 500 models of clear aligner to produce a day. And if your business grows very fast, after 1 or 2 years, you have like 100 patients a day to deal with. So you are facing like around 5,000 models and clear aligners a day to produce. That's quite very challenge for many dental labs, because for normal dental labs, if you have like 100 cases a day or 200 cases a day, that's very kind of big scale. If you want to print 5,000, that's huge scale. So upon this, what kind of solutions we can provide? Sometimes some of our customers choose to buy the machines by their own. They buy 3D printers, they buy post-curing units, laser engraving units, thermoforming machine, and a milling machine. So they buy all the machines which they can establish a production line, very automatic and intelligent production line, especially for clear aligner productions. But you can buy all the machines if you have money to buy it, but you can never integrate it, because each machine, they have each different kind of manufacturers, they have their own softwares, hardwares. It's very hard to be compatible to each other. And there's no way they can think about like, I will special design for clear aligners. So what you can do then, let me go through the cost structures we are facing right now. For many labs, they learned that actually for material and expense is not the huge part of the entire cost of each clear aligners they produce. Actually, the labor cost is takes most of the way. For our statistics, we calculate is more than 50% of the cost is on labor. So, and the labor is a cost that is not going to decrease as your business scaled. The material will decrease, because as you scaled, you use a lot of materials to talk to some manufacturing suppliers to decrease some price and something. So you can have a better price and better cost on material and expense. But for labor, will increase, because if you are dealing with small team, your management will be very flexible. If you are dealing with very big teams, your management will be very challenging. So what we do to reduce the labor cost and try to reduce the all cost and make the production very smart and very automatic. There's two ways right now, two options for our customers they can choose. Either to integrate the production by themselves or get a customized production lines. If you want to integrate production by yourself, then you are facing three challenges. One is your production line is very low efficiency. Two, the material consumption and all the consumptions is very high. And it's not flexible. When you want to scale, you need to choose another machine. And you say, okay, I buy a small machine for today, I maybe buy a big machine for last year and for next year. But that is not going to work. And for some customers, they choose, okay, I can spend a lot of money to customize the production lines, which is very expensive because you need a team, engineering team, to help you to establish a production line for your facility. If you change your facility, you need to move the machine and you need to ask them to pay them again to help you to establish the production line. And it requires you have your own engineer team. So then they can maintain the machines, maintain the production line in order to run it very fluently. And the third is if you want to change your production way, you want to change your workflow, or you want to change your scale, it's very difficult to change. And normally some customers start very small, like a few cases a day. They want to give a try to see if the market it makes sense. And they want to go scales later, maybe 1 or 2 years later. And maybe they will go to scale very rapidly and very fast. So for that, customized production line cannot satisfy that because you cannot pay for 1 year later your scales, and now you are using that very low efficient. So we are considering, is there the third options we can choose? If there's third options, and what kind of options it should be. So right now, for HeyGears, we have a third options, which is affordable, reliable, and flexible systems, especially designed and made for clear aligner workflow. For affordables, it's like if you are small scale, you can afford that. And if you are a big scale, you can also afford that. And the production line will grow as your business grows. For reliable, it's not like if you establish your production line by yourself, you need to consider about the software, hardware integrated together and the reliability of each of the units. If one unit breaks, your entire production line is down. So for HeyGears production line, the reliable is very important. So our entire production line is very solid, and for each part, we can identify the problems, issues, and we will give a long test and make sure the entire production line will run very, very good. So, and the flexible is we can give you different kind of solutions for different scales and different production ways, your own workflow and your own thoughts about clear aligners. So this is what we can provide. Before all of that, we did need a data brain. The data brain can help you to process, to receive, and to send the data workflow among the entire production systems. Okay, let's check out what kind of the brains we are using. So right now we can see we divide the entire production steps into different ways. Let me introduce you one by one and see what kind of things is within this step and what kind of solutions HeyGears provides. So first, we need to deal with the data after design and after scanning. We have our automated data process systems will help you with few clicks to automatically process all the clear aligner models and very fast, very efficient. So we divide it into 4 steps. First is the shelling. Shelling will give you a way that you use your material very efficient, will at least reduce 40% of the material consumptions. And it also gives you a very lightweight, hollow, and very fast printing speed. Adding fixtures will help you to add 3-point triangle fixtures, will help you to fix that, position the models into milling machine. And also that is another reference to coordinate systems to our trimlines we detected later. And you need a placement. If you are dealing with like 100 or 200 models a day, you don't want to place a model one by one each to the platforms. So you will calculate most efficient way, space efficient way to place all the models on the platforms. The first is slicing. We use different algorithms to make the slice very fast, will happen within seconds. So you don't have to wait for minutes before you can print. And another is we develop some automated trimline detection algorithms. Will help you to detect the trimlines you want to deal with these models. These trimlines will generate the G code to the milling machine, and the milling machine can read it and mill the trimlines after you thermoform the blankets on the models. So let's go to check it out what kind of systems we are dealing with, what kind of software we are using right now. We have our stream flow systems. Stream flow system is a system that doesn't depend on the functions, it only depends on the workflow and applications. So in this system, we can see this is my account. So my account, I am dealing with 3 different applications, use different machines and materials. If for some labs, different users, you can customize your own workflow with our systems, and our engineer will help you to do that. So for each page you are logging in for different users, you are looking into different page, different icons, different apps. For different app, if we'll combine with printer information, resin information, and application information. And for each app, the workflow is specially designed and customized for your own lab, your own workflow. So it won't happen like if you are using theirs and I'm using mine, that's the same, or we have different understandings, then we don't have to use the same systems. So this is our system that is very flexible and can customize for different users. So today I'm choosing the UltraCraft A2D Ortho as our printer, and the model TF2.0 UV as my resins. And this is special application for clear aligners. So, and I will import all the files I want to deal with. I imported 6 files and they all uploaded to the systems. Right now you can see for 6 different models is in different positions and orientations. For this orientation, you cannot deal with that. We need to be very flat. So when I start the workflow, you automatically to adjust the orientation to the right way. After that, we will detect the trim line. After detect the trim lines, we can see we divided the 6 model to 2 groups. Each group has 3 models, including upjaw and the lower jaw groups. So this are all automatic to detect which one is which. And I'm going to detect the first models now. We'll generate the trim lines just a second. Okay, I can see it's very nice trim lines is generated by the models. And for these trim lines, we can see many points, and some points is not in the turning point. Doesn't matter because this only shows you the points you want to adjust. But you can also create the points like here. Then I can adjust a little bit for more precise adjustments. And you can change it by yourself. If you think this trim line is too sharp, it's too near to teeth, no problem, you still can change that. We can change the angle between between the lines, so we can have a smoothen lines. If you want to more smooth, we can also go with that. And if you want to the trim lines below your teeth, we also can adjust that. So there's many parameters you can adjust by yourself, and you can also change it as the way you want. See? Okay, after that, I can confirm my first model. After confirming my first model, the adjustment of the first model will be a reference for the following models, because for each of the steps it changes a little bit, so that won't be a very huge problem. And it will also increase the speed and more precise for the following models. So I will go batch detection. After batch detection, we can see it's all detected as you want. And I can confirm all at once. I will repeat the same steps as the lower jaw. Okay, I can see this point is not nice, so I will change it. Okay, so I think it's a nice line. I will confirm it and go batch detection. So I will confirm all that. After confirming all, I have 6 models with different trim lines detected and saved and confirmed. The second part, I will hollow the entire models. That's the way we save the material up to 40% and also increase the printing speed. Okay, we finished. Let me show you one thing that is different than others. You can see the shape of here is like the Minecraft or Lego. Why is that? Because we use a different algorithm we call voxel algorithms. Instead, using the mesh algorithm, which use the points, lines, and the surface to create an object, we use a voxel like a Lego or like the Minecraft to create the object. So when we adding the object, it's very fast to add. As you can see, takes seconds to hollow that. That is never happened with the mesh algorithms. So you just the system just simply take out or add the voxels as you are playing with Lego. So this gives you a very fast way. And for the surface, we can see it's still mesh way. So this gives you better look and better details of the models. We combine 2 algorithms together, so make this system very smart and efficient. After we hollow that, we will add fixture. In previous slides, I introduced you the fixtures is kind of reference coordinates to the points of the trim lines, also help you to fix the positions on the mini machine. So we developed some these 3-point fixtures will form a triangle, and this triangle is very stable on the machine. So you detect the points is best way to add the fixtures and automatically add it on it. If we want to adjust the positions, you can also adjust that very simple and very easy to do that. But normally, after we test, almost 95% is success for just added automatically, so you don't have to adjust yourself. Only for very special case, you can do that. After that, we need to place all the models on the platform. This step is also automatically processed. Very quick to finish. This is the platform for our A2D Ortho. So maximum you can place 8 models, but for these models and only have 6, so you place very give you save a lot of space to place that. And the slicing is very quick. It takes seconds to slice it, and the file will be sent to the machine. So this is all the steps you need to do on the streamflow systems you want to deal with all the data processing. Afterwards is hardware's job. So let's go back to what our hardware and the systems can do. For hardware, we divide it into 2 parts. One is printing and the post-processing parts. For the printing, we have our 24/7 automated production systems. we will make every minute count, which means you save your every minute when using the printers. No longer you want to print at daylight or you want to print after you sleep. You can run it by itself. So this is the most efficient way you can do, and will make your entire production very fluent. So first, we have two systems added on the printers. One is automated material filling systems. It will fill the materials automatically because it has sensors to detect the liquid level. After detecting the liquid level, after printing or before printing, you will add the liquid to the resin tank to make sure the liquid level is on the same always. And then we have our Hive module. It's a robot arm module that will have two functions. The first function is will remove the parts from the platform. We will take the platform from the printers and fix that to the Hive systems, and there's a blade. We'll cut the models from the platforms. You will cut it by itself. So, and there's a tank that will collect the models from the platforms. So you can collect at least 200 models per tank. And the robot arm will do the job to switch the platform from the printers to the Hive module and from the Hive module to the printer automatically. So the entire system keep you running 24/7, and you don't have to worry about the printing situation and everything. You don't have to watch, oh, it's done the printing, I need to take out the models, I need to fill the resins or anything like that. It will help you to automatically to do that. In these systems, the speed is around 16 minutes. We can print at least 8 clear aligner models. And for now, we are also optimizing the softwares intended to give you better speed. And in these systems, you can print at least 220 models a day. Let me introduce you about the systems here. Okay, this is our A2D Ortho. You can see the lights here. It shows the progress of the printing. It doesn't show the number, but it's a very rough progress. You can see before I started the webinar, we start printing. So right now it's almost finished. And there's a screen here which shows every detail of the printing situation, numbers, parameters, and everything. This is our material filling systems. It has a tank inside that will contain at least 3 kilograms of the materials. And there's two openers. One is you need to fill the material from here, and the tube goes from there. So you won't interfere with each other. And this is our Hive module. For the Hive module, we have lights here that show the status of the Hive. And we have a robot arm here. We'll take the platform from the printer to here. And you can see we have a blade here. That's the blade that will cut the models. The blade almost runs 2,000 to 4,000 times. You need to change another blade. And for this plate, we will collect all the following jobs that's from the models. After you printing and collect all the models here, so there's a tank that will collect all the models here. It collects at least 200 models. Normally for 3 kilograms of the material, you can run like 8 hours. So for each 8 hours, you need to collect and to refill the tank. And we also have a very nice design here. There's a little room here. You can save the material and save the resin tank, extra platforms here. So you can replace it from your storage. Okay, this is the introduction of whole systems. Let's see, the system is finished right now. And this after printing, the platform will goes up and the case will goes up, and the robot arm will take the platform to cut the models from there. So this after printing, the platform will go up and go down to the levels that's easy for the robot arms to collect. So afterwards, the robot arm will be here to collect the platform and cut the models from there. So we'll run 24/7 for this. Okay, let's go to slides. And the most important thing is the materials. Sometimes the machine is very important, but the material is more important. Sometimes materials residue will restrict the automatic productions. So we develop some of our own material, dental polymers will provide high speed and with lower viscosity. It will be exclusive material that's especially designed for 24/7 running of automatic printing. Right now we have two different materials. First is our water washable materials is here. This is our water washable material. It's very special material that will be soluble to the waters. So you can use the water to wash that, don't have to use isopropyl or alcohol to wash that. It's very environmental friendly and print high speed, very high precision and high structure stabilities and everything. We also have the very standard material we call model TF for thermoforming purpose. This is the solution-based material for alcohol washing, for isopropyl washing. So it has same physical property as this one. So we can see the system opened, and the robot arm will be here to collect the objects. The robot arm will unlock the platform first and take out the platform. And take the platform back to our part remove machine. For the part remove machine, there's also the solo ones you can buy. That's manual. It's not like Hive system use a robot arm to control. It's a manual control. So it's also single machine you can buy for A2D Ortho. And the cut machine will move back, and the blade will cut the models from the platforms. After that, you don't have to worry about there's any residue left on the platform or anything. It's very clean cut. We have done thousands of times testing, so it's very reliable, very clean. And afterwards, we'll take the platform from the Hive module to the printers and to do the printing again. So this is like full automatic circle will run afterwards. Okay, let's go back to slides. And for the post-processing systems, we have our thermoforming, label lasering, and the trimming all the lineups that will help you to from the printing to final clear aligner productions. And we create our own OCR matching machines. For each model, it has its own ID. Because the ID will be their own identifications that will run afterwards. Then you don't have to worry about if you mess up with different patients or you mess up with different models and everything. It has our own identity. So afterwards, we will be matching with the label lasering information, trimming information, and everything. We have a 7-digit number that is engraved in the each models. This will happen when at the same time as we process our data, but we didn't show you that because it's a background process, so it won't show on the interface. And after that, we detect the OCR systems and to match the sequence from our systems to see, okay, which models we are dealing with and what kind of label lasering information we can use for these models and what kind of trimming files we can use for that models. So it's smart systems will help you to identify which is which, and you don't have to worry about sorting between each steps, and you don't have to worry about, okay, I break these models, I need to print again. Okay, after printing, I don't know which one is which, and these models belong to which patients. For label lasering, we use UV lasers. After OCR detections, we will UV laser the information of the patients, step informations, and every information, even your brand logos on it. And automated trimming machines will help you to trim to cut the trim lines from the models and give you the very clear cut and clear liners. For automated trimming systems, it includes actually 4 steps to accomplish these functions. One is trimming line detections, that's for the data purpose, and fixture adding, that's for you fix your models into the positions on the mini machine, and it helps you to identify it's a reference, coordinated reference as your trim lines to each point. And we have algorithm optimizations for the when you're trimming, you won't happen to contact or touch or click between the points, and help you to optimize the entire algorithm for the models process. We have our trimming systems that will give you best angle to trim the lines very clear and fast. So let's see from here. We use GIF thermoforming system. This is not from us, but we think it's good. So we use these machines to do the thermoforming. Afterwards, after thermoforming, this is the models from the machine, and after washing and post-curing, you have very nice detailed models. You can see on each model, the bottom, there's digits of the OCR code here, and the 3-point fixtures adding here. And there's a bottom web shape bottom that will help you to hold the shape and with limit deformation of the entire models right here. So after that, you place your models here and place your blankets here to do the thermoforming. After that, we will have our thermoformed models with the blankets together. And indeed, we have our OCR code here. Okay, let me show you how I can use our OCR system to label laser on this foil. First, I need to put my eyewears on because eye protection is most important. And afterwards, we can see this is our OCR system. Our OCR system, that's the digits that show up. There's this is screens that will show a kind of pictures you can provide. And for that, there's a little fence here, you can see. After your hand goes in, you will detect, okay, your hands goes in. And after that, it's going out. So it will help you to detect when you need to trigger the detection, when you don't need to trigger it. So if you put your blankets in that, then your hands leave it, it will show you, okay, we have something I need to detect right now. And after you take it, okay, I can sense your hands is already left, so I don't have to detect that. And there's a ring here. It's easy. You help you to place the blankets here, and you can place as any angles you can do. It doesn't matter. So you can place randomly. You detect the sequence here. So this is a code, and it shows you what kind of the information you need to mark on on the blankets, and this shows you where you can do that. After that, I will get these foils to the laboratory machines here. Okay, after finding the right place with the red dot, I can simply click here and start to laboratory. Okay, only take 2 seconds, 1 second to finish that is very easy. So I don't know if we can see that because it's a very small label here. So it's very clear labels on here, and you can adjust the size of the letters and the different fonts of the letters and the different shape. You can also add the logos or any other information if there's space good enough for you uh, for the teeth. So you can also add in that. So it's very easy to finish one. Okay, I finished one here. Let me finish 3 others, see how fast I can do that. Okay, I've detect the problem. Place, click. Okay, I got another one. So there's another function I didn't tell you. It's very curious because this function we thought a lot about this one, but we think it's very useful. You can see for different models, the height of the model is very different. Sometimes if you don't change, normally we use this to swing up and swing down for better focus. Then we have a clear words that we engrave on the blankets, but they will take too much time and too much experience for the workers here to do that. So we have our sensors here. We integrate the sensors here. We detect the height of here, and we'll automatically to adjust the focus. Let's see if we place some height here, what it can do. Okay, let's see if I detect these models here and place here. It's different heights right now, so see what we can do right now. You can see detects, okay, it's not the same height. Okay, I need to change. I can go up and find a better focus here and to engrave. Okay, that's done. Very nice. So after I finish 3 labeling here, we also have an OCR system that's combined with our milling systems here. For our OCR systems, is the shape is different, is same, but the software is a little bit different. It's compatible with the. Sorry, I need to take this off. The software is quite different because the different information need to be focused and confirmed. Now I just put the blankets on the OCR system. You can read the code sequence. Okay, you see it's wrong. Doesn't matter. You can change it away and do that again. Why is that? Because for some blankets there are some brand logos here, so will that interfere the recognition of the OCR systems. Okay. Meanwhile, you send the files from here. After recognizing which file is it, you send the files to here. Let's see. And after that, you can check. You can refresh here. So you can check if the files is the same with your file. Okay, this file is the same. I will load it. This is all the G codes loaded on the machine. I will open the machine and, sorry. This is a fixture, 3-point fixture here, according to the 3 points here. And there's a vacuum. You suck down the blankets tighter. So you just place the models here and you close the door, press the start. You will just simply start it. Sometimes normally it takes 40 seconds to mill one models. Take another 20 seconds for OCR recognitions, and you're manipulating with your softwares, tools, and everything. So average time is a minute to finish one trimming. Okay. After that, we can see there's a little brush here to take out all the dust. So you can see we have very clear, even shaped, even gapped trim lines from here. Okay, I can just simply take it out. Sorry, it's a little tight here. You can see after trimming, the edge is very smooth, and you can do simple polishing to get a better feeling of the edge. This is how you mill one. And this one, the trim line is not very sharp, so it's very rounded. But for some other special case, you can also adjust the trim lines to be very sharp, more with the gum lines, so it can give you better sharper milling. Let's do another two, see how fast you can do. So I detect the sequence and confirm. The file is sent to here. Refresh. I will see, okay, same file, and I put it here. Okay. Let's close. Let's get a job. In the meanwhile, you can also see this is untrimmed blankets. You can also go with the OCR detections and get the files. And you can see the files here. You can see the files same here. So you can load before you finish this job. Then you only have one time to, okay? Oh, sorry, my bad. Don't know. Okay, sorry. I will take out first. Can you help me with how to reset that? Okay. Sorry, my bad. Okay, I will load another files after scanned. I will load it here. Let's start do the trimming again. The entire trimming is very fast and very clear, so you can trim all days. This is all the blankets we trimmed before the webinar. So these very sharp trims, very smooth trims. You can choose either way. You can do with a foil, without foil, different blankets or test it. So this system is very reliable and very efficient. Okay, let's go back to slides. After that, is that all for the solutions? Is that all for our digitalizations? I will say no, because we have more. You have so many systems, hardwares, and softwares. You need something to manage all the systems, right? So we have our UltraNet systems. You can manage all the units, printers, mini machine, and everything based on HeyGears systems. And you can also watch that, what's the status, what's the parameters, and what is going on. And you can monitor that remotely or in the same rooms. You can do that. If you are many different printing rooms, you can monitor that with monitoring centers you can build up. So you can control or see all the situations of the entire systems, including printing lists, including material consumption, temperature, humidity, and the readings from the sensors. This also help you and help our engineer to retrieve the problems and know what is going on with the entire system. After that, we have also our production management will help you to manage all the productions in different times, if it's delayed or on time, help you to have a visualization for your entire productions. So including these management systems and our material, software, and hardware, we combine and integrate together to form our clear aligner workflow, provides very reliable, affordable, and um, uh, the systems that you can use. So for the entire systems, we have these diagrams. On the left, it shows you all the softwares you use, including the post-processing softwares, labeling softwares, trim line detection softwares, and everything. And on the right side, you can see we have our material and all the hardware units you are using. Together, we form our automated workflow. This is HeyGears provides flexible and reliable clear aligner mass production systems, which also is affordable for your lab. Okay, thank you. That's my introduction. So I see there's many questions from the guests. Let's see what kind of production questions we have right now. Okay, so the first question is about the aligner plastic plates should be able to fit two arches. Okay, I understand this. These are blankets, and this is the models. Normally, we place one models here, to one blanket, one model. But for sometimes, if the model is smaller, and you rather to save the material for the blankets, sometimes you can place in this way. You can do that, but there's two problems there. First, for different blankets, it has the same thickness. After thermoforming stretched, the thickness will be lower. So after you place two, the thickness will be much lower than usual. So this will influence your treatment first. Second, for the milling machine, it's very hard to do that when you have interference with different models, and it's very hard to do. And you can see we have a vacuum in the center of the models. We'll suck down the blankets, help you to more stable the models on the fixture. So after you cutting here, it's very hard to suck here, and very hard to place the models, because you can see there's a 3-point fixture here. If you have two models, what kind of coordinates I can do? I have two coordinates here, so it's you never can do that. So it's very hard for now for you to place two that, but you can think about if you can cut it before milling and use another different type of fixtures that doesn't have the vacuum in the center. Maybe it's possible to use this technique. Sorry. Let's see another question. Once the stream flow detects a gum line for a case, is it possible to set it as default for the same case? Yes, this is very nice questions. As I show you with the streamflow software, you can see when I adjust the trim lines as the first step, it also help you to adjust the trim lines from the following steps. That's the first reference that will for the following steps. So help the algorithm to be optimized for following step calculation, also save times. Uh, Okay, and that question is about why I opened the door and the entire mini machine is stopped. Because when I open the door, you trigger the protection systems. The protection systems will protect me from getting injured from the machine. So we'll stop the milling and stop everything. When I do that, I reset that. Will reset all the movement and machine to the center. So afterwards, I can repeat the job again. Is the whole process, including machines, available now? Actually, for the all the process machines, we already download test. We have our alpha test. Some of our customers already using that. But for the label lasering machines, we are restructured that because this one doesn't has protect. So we have our new ones on the way. We will launch soon. So our system will be available very soon. And some of our alpha test customers already use that for months. So that's very nice system, they think. And we are also upgrading our system entirely, both for hardware and software. So we call this version is 1.0. We already finished and we are working on 2.0 right now. Um, can you load multiple jobs into the trim mini machine on no need to scan it one by one? Yes, I showed you with the mini machine that I scanned one and mill one, and I can scan another one and waiting the first one to be finished, and we can load the files for the next one. Actually, you can scan and load different ones, but you need to sequence the models one by one in order to, in case you will mess up with each other. And you can check with the numbers, the OCR sequence, and to see if that matches the file. If it matches, you can load. So that won't be a problem with that. Okay, that's all for Q&A part. Thank you very much for me and for our introductions. The last part is about the service you can do. There's a little service for HeyGears webinars. You can please fill out the form and you can say something about our performance and our system technology and everything. So for future improvement. Thank you. Also, if you have any questions or further suggestions, you can email us or contact us for further information you are interested in entire system. If you want to try or want some samples, you can contact us and contact our US office. They will send you more information as you need. Ah, that's too bad. Sorry, there's a malfunction about the computer and the camera. After the survey, the entire HeyGears webinar today is finished. Thank you all for joining us for this webinar. We welcome you to contact us. And we also thank AMT for this chance for us to introduce HeyGears entire clear aligner solutions. Have a nice day. Have a nice weekend. Thank you.